Okay, so let's start another session. So find your seats. Thank you. The next topic is fearless upgrade with Fedora Atomic Workstation, presented by Jonathan Lebon.
Yeah, that would help, yes. Okay. So how many of you were in Calif's talk in this very room at 12:30? Yeah? Okay, not a lot of people. That's a good thing because there's some overlap between the two. For those of you who were there, I'll try to, it's a different perspective from how Calif presented it. So how many of you use Fedora Workstation Edition right now? Okay, that's good. So I'm going to try to convince you to use Atomic Workstation. So I guess this is what we're going to be approaching in this session. What is Atomic Workstation? Why should you use Atomic Workstation? And how you can get started with Atomic Workstation. So what is Atomic Workstation? So it's basically a union of the Fedora Workstation Edition with the Project Atomic pattern. So in other words, its goal is to basically address the same use cases that Workstation is designed to answer, but it brings the architecture improvements that the Project Atomic pattern provides. So what does that mean? So this is a really crappy diagram, but so you have basically your OS3 base OS, and then you have your desktop applications in flatpaks, and then you have container applications in containers. So this little dog here is supposed to be your pet container, and I'll talk a little bit more about that later. You could have like HTTPD running, and then if you want to do some like server app hacking, you can use OC cluster up and just hack in there. But notice Apache is running in the container, right? It's not in the base OS. So if you get either Atomic Host or Atomic Workstation right now, you're not going to have Apache in there. So why should you use this? Why would you restrict yourself to these kinds of delimitations? So the huge, I would say like 70% of the reason why you should switch to Atomic Workstation is transactional updates. So if you think about the classic like pet, cattle, or I think there's like a different analogy now that's preferred. But your laptop or desktop is literally the stereotypical pet case, right? Like you care very much about your workstation. That's how you do your work every day, and that's how you look at cat pictures. So you really don't want anything bad to happen to it. So if you compare that to the server case, right, which Atomic Host is designed to address, most of the time, it's pretty easy to replace a server if something goes wrong, right? So you can just, if you're following good guidelines, you have like an Ansible playbook or something to reprovision a new server. But that's kind of, unless you're very disciplined, you probably don't have that kind of setup for your workstation. You're not going to have playbooks and stuff. Some people do, not me at least. So transactional updates in the workstation actually makes even more sense than in the server case because you really want it to always be working. So the problem is that DNF or RPM updates are inherently unsafe. And I don't just mean the whole problem with postscripts, and there was another really great talk about RPM scriptlets and why that's so very wrong for a lot of reasons. But it's just inherently unsafe because your RPM database is being mutated in live, basically. So if anything happens, if power gets cut off or a cosmic ray hits your RAM at the wrong spot, you're basically in this transitional state where some packages are updated, some packages are not. So actually, this is a really cool blog post by Adam Williamson. I don't know if, he is here. Yeah, so this was posted 2 years ago. So basically what would happen is if you upgrade your workstation from an X session, you would basically crash your system because the systemd udev service, or RPM, would restart the systemd udev service, and that would basically crash everything. So the recommendation is don't update your system by running DNF from the desktop. So, yeah. So basically the workaround that Adam suggests is you can use package kit offline update support, right? But even in that case, you're still not escaping that huge window of maintenance or downtime where if anything happens, you're screwed, right? You're in that transitional state. So compare that to transitional updates. You have no fear, and that's why my talk is called Fearless Upgrades, because you really, really don't have to worry. So here, just for fun, I provisioned a CentOS Atomic host system, and I literally just rebased to Fedora 27 and rebooted into Fedora 27, and it just works, you know? And even if it didn't work, I can always roll back and go back to CentOS. And actually, I did that just to make sure that there isn't some kind of like, there aren't applications that migrate their databases, and for some reason it doesn't work if you go back to CentOS or something like that. So the second part of it, the second huge sell point, I guess, of rpm-ostree is immutability and isolation. So this is a really, really funny thing that I found on GitHub. Basically, the author of the install script added an extra space right there. And basically, that made the install script wipe out all of user, and then people just complain about it. And this reply was really funny. Bleeding edge, really bleeding for someone now. So in Atomic Workstation, right, your base OS is immutable by default. So that does mean you can't, for example, just do pip install, Ansible or whatever you want, right? But it also means you can't have things like this happen. Now, remember, this is unintentional, right? The maintainer obviously didn't mean to write this. So even if you try to be careful of not, you're going to say, oh, I'm never going to install RPMs. I don't know where they come from. But that's not the point, right? Even unintentional damage is possible. So anyway, as far as like hacking goes, like if you want to have a virtual env container or whatever, that really belongs in a container, right? Something away from your host. And the reason for that is that you want to have as few things as possible in your critical path to a successful boot. Like, you don't need pip in your base OS system to boot. That's just, you don't want pip in your critical path. You don't need GCC, you don't need clang, any of that stuff, right? So all that stuff belongs in a container where it's just far, far away from your base OS. So then a natural pattern that emerges from this is, the use of pet containers, and that's something that Colin talked about this morning. But yeah, basically, well, Colin showed the command he uses, so I won't show you mine, but it's very similar to his. So actually, let me go back here. So not just containers are, oh my God, 10 minutes. All right, so not just containers are contained, but are not just like your development environment is contained, but also your applications, your Flatpak apps run in Flatpak. Now, Flatpak is not super secure right now, but at least it's running in its own mount namespace, so you're not polluting your root file system with those things. So the other great thing about using Atomic Workstation is effortless change tracking. So basically, the base OS tree that you get from Upstream, from Fedora, has a certain set of RPMs, right? And if you want, you can remove a specific package. You can replace other packages by new ones, or you can just add a whole new package completely. And the really cool thing about this, and obviously this is something you can do if you download regular Workstation. Obviously you can delete packages and replace. But rpm-ostree keeps track of exactly what you change from vanilla Upstream, right? So it's really easy for you to see how you can go back to vanilla mode. So one thing that I really want to hack on, actually, just for fun, is sort of like an atomic nuke command, which basically deletes all the modifications you've made, restores all the etc defaults, and it's like kind of like a factory reset mode in Windows, at least a mode where you don't wipe out your application state or your documents, or we can support that too. But just to show you, does that, oh yeah, that's not going to work, eh? Okay. Yes, it is. Yes. Okay, so, right, so, yes. So this looks like crap, so let me just go a little lower. So basically, this is my laptop, right? I'm running Atomic Workstation. And is there a laser on this? Oh, yeah. OK, so I'm on version 2748. And I have this base commit from Upstream. So we can all talk about the same version, right? I can be like, oh, yeah, I'm on 2748. It's like, oh, me too. Cool. OK, well, let's file a bug about it. In this case, I replaced Docker from version 42 to version 44 because, oh, it's trimmed, but because there was a bug in Docker that prevented me from running my pet containers. And I layered these packages, right? So obviously, in the Atomic Workstation case, you're going to want to have some things on your system that doesn't really make sense in a container. So yeah, just the fact that you can layer these packages directly on. Like, I want to be able to do Vim everywhere, right? Where's my Vim? There's my Vim, right? You want to be able to do Vim anywhere, right? So you really have this powerful semantics of knowing exactly what you changed from Upstream, and you know exactly how to go back to that Upstream copy. Yes, that works. So another cool thing is upstream testing. So basically, instead of a stream of package updates, so this is kind of not a too fair comparison because Bodhi does like batch updates now. So it's not that, like, I guess this is like a time axis right here. But yeah, like you just have random packages and you can only do tests really at the package level. Whereas in Atomic Workstation or Atomic Host, we can do tests at the OS level, right? So you have a whole other way of testing that's much more meaningful to the end user. So from your perspective, I guess what I'm trying to say is it's way less likely for an update to break a computer. Now, we're not doing a lot of testing right now upstream for Atomic Workstation at least, but that's something we can very easily do in the future, right? Another cool thing is automatic updates. So this is something we've been working on upstream. And the cool thing with that is, you know, it's really cheap in pure OS3 mode. If you're not using layered packages, it's really cheap to detect what updates are available. And it can tell you exactly, you know, what the diff is from what you currently have running. So it can say, oh, yeah, there's an update which brings the kernel up to version 4.14.11. And these are the advisories that are open right now for the package you have installed. Now, this is something you can do on DNF too. That's true. You can do DNF list_sec. But it just makes so much sense to visualize updates as units, and you know exactly what you're going to get when you upgrade, right? There's no like disconnect between the two. And this is only phase one too, right? The cool thing with automatic updates is what we really want to do is it sort of prepares the updated deployment in the background for you, because we can do that. We do all our updates in the background, and then you just have to reboot, and you just reboot directly into the updated deployment. So really minimal downtime. And I think that's it. So yeah, so how can you get started with Atomic Workstation? You can download and install the ISO for Fedora 27, or if you're brave, Fedora Rawhide. Or you can also install inside, I guess, an existing system, which is what I did with my laptop. So it allows you to sort of like test the waters before fully switching over. And yeah, then you can like fully commit and move your data over once you're ready. You can check out Workstation OS3 config on Pagure for more information on how to do that exactly. If you need help, you know, there's the Atomic channel, the Flatpak channel if it's a problem with Flatpak, Atomic mailing lists, Bugzilla, or you can file upstream issues. We're pretty good at responding quickly to critical issues. And that's it. So to summarize, you want to use Atomic Workstation if you're a developer because of transactional updates, immutability and isolation, effortless change tracking, upstream testing, and automatic updates. And I say if you're a developer because there's still some rough edges, and we still expect you to know some things so that you can, for example, like the pet container stuff, that's something we have to polish up for a wider audience. So yeah, try it out. And that's it. Questions? Is it very, sorry?
Like, is it ready for sales teams? I have sales teams in my company and I would like to switch over from something is they're ready for this.
The question was, is this ready, for example, for a sales team? Because I keep mentioning developers. I would say not Atomic Workstation right now as it is, but yeah, like I guess a pattern that we want to be able to support is like, you know, the corporate standard build laptops, which for that you would create your own OS tree normally if you're using your own, if you're in your own company and you have your own requirements. But yeah, this is something that, like, if you create your own OS tree, like, that'll just work. We're not doing anything special there, right? Like Colin said, we're literally just taking RPMs and creating OS tree commits. Anything else? Oh, so sorry. Yes. The impact on memory? Ah, okay. Do you mean memory like RAM or storage? Oh, both. Okay. That's a good question. So I think, so sorry. So what's the impact of this model on memory and performance? So for memory, I guess at the storage level, everything is deduped because we're using OS tree, right? So you're only storing a file once, even if you have two different deployments. Anything that's shared between those deployments is shared. And Flatpak 2 uses OS tree for storage, so you have a lot of sharing there. For RAM, I guess, I don't know, there's so many ways to answer that. I guess, offhand, like Docker, for example, if you're using, in Docker, normally you have shared objects between, the mapping of libraries can be shared between different Docker containers if you're using the right backend, right? So you can have like 10 JVMs or whatever. But for performance, that's a good question. I guess it wouldn't be worse. I don't think it would be worse. I don't know. I'm not sure how to think about performance in that way. I think it would just be, yeah, on par with regular Fedora Workstation. Yeah.
They're going to take support penalties, right?
No, yeah. It's not slow, yeah.
Basically all the same bits, prepackaged in different ways.
Exactly, yeah. It's the same thing that you would normally have outside. It's just that it's separated for good reasons. Yeah. Any other questions? Yeah.
So, for example, the base container is, let's say, 350 megabytes, right? And the newer version of this container is because the kernel got updated. If I do update, do I fetch 350 megabytes of the whole new container, or do I fetch only changes?
Right. So when you say container, that you're talking about the OS tree base commit, right? Like the base. Right. So, the question was if there's like a kernel update, do you have to re-download the whole kernel again, or like the whole? Yeah, everything. The answer is it depends. In OS tree mode, it's like Git, right? So you're only downloading the file objects that you don't have on your file system in your local OS tree repo. That said, OS tree has this feature now called static deltas, which basically allows you to optimize for the case between two specific versions. So like right now, I'm at 2748. When 2749 comes out, there can be a static delta between 48 and 49 to only have, like it does like a binary diff of your objects, and then you're not going to download all of the files.
Let's do an example. A single file and a single RPM changes. What do I have?
A single file. Yeah. Thank you, Dusty.
And also the RPM database.
Yeah, okay, that's a good point. Yeah, so a single file, so 8 files, I guess. Or 9, yeah. Any other questions?
Also worth adding to this that as soon as you involve package layer, it's just using the so it behaves the same as package system on the client side.
Right. Yeah. Yes?
So Upstream updates are probably much faster than DNF or YAML updates, traditional package updates. Did you compare how much faster they are?
I'll say, oh, sorry, the question was how much faster are OS3 updates compared to regular DNF updates? Again, that depends, but overall it's going to be way faster normally because the most likely case is that a lot of your things are shared with whatever the target state of the update is. So you're not going to be downloading a lot. Whereas in DNF, you're going to be downloading all of those new RPMs, right? And it doesn't do... Yes, exactly. So that's the problem too. If you're in hybrid mode where you have some packages layered, so we're going to be downloading OS3 stuff, and we have to go through the RPM metadata download and libsolve and all that stuff. So you don't fully escape from RPM MD problems, but that's just the nature of the beast. Yeah. Any other questions? Cool. Thank you.
Not from all.
Thank you.
One question.
Yes.
How it is prepared for developers like, is it in base image, Docker, and libvirt and other things or not?
Yeah, basically, depending on what you're... Oh, so sorry, yeah.
Mike?
Yes.